Greetings duplicant and welcome to the breach. In today's episode we build the power brick and then we move on to the other colony to build the petroleum boiler. First thing we're going to do is build some coal generators. This is going to be our backup power supply to make sure that we don't lose power to the base. Because if we lose power to the base, that means the toilets run out of water and the duplicants start having accidents everywhere, which is unpleasant for everybody involved. I chose coal generators because I have got about 500 tons of the stuff, and also that it doesn't require any extra plumbing for pollution. These coal generators will make it a lot less complicated to build the new power brick. I can rip out all the other power generators with impunity, and as long as these are powered and connected to the power transformers, I will still have power. We'll just make sure that the coal generators are topped up with fuel. So we're building the power brick over the top of our temporary power generation setup, which makes things easier and harder at the same time. It makes it easier because all the resources have already been shipped here already, but we do have to untangle our previous setup. Across the top we have our natural gas storage. Unfortunately, both our natural gas vents on this map go off at about the same time. Below that we have our hydrogen generators. This is taking the excess hydrogen from our self-powered oxygen maker. A small reserve is also stored over here, but automation is set up to burn off the excess. Below that we have our petroleum generators and storage. As I'm building a petroleum boiler, this will be our primary means of power production, relegating the natural gas to backup until when we produce a sour gas boiler. The coal generators are emergency backup, and the natural gas generators are at the bottom. All the polluted water from the natural gas generators and the petroleum generators is collected and shipped off. But most importantly, the reason why I built this kind of industrial brick setup is all the carbon dioxide is located in one place, and we're going to be feeding that to slicksters. We are burning a little bit of power to heat the carbon dioxide up. That's because the vent is releasing the carbon dioxide at a very low temperature, so we want to make sure that that doesn't kill off our slicksters. This has changed our food into a renewable resource. As long as we're producing power, we will have food. And over to the main event, building the petroleum generator. It's been a very long time since I've built one of these. This setup will use liquid lead to extract the heat from the igneous rocks when it's in debris form. This type of boiler gets more efficient the longer you run it, and once I switch it on I don't switch it off again. So if in the future I decide to upgrade to a sour gas boiler, my input will already be petroleum. On a side note, if you're photosensitive, warning, there might be some strobing petroleum. As you can see, I've vacuumed out the whole area where I'll be working. Gases and magma don't mix and play nicely together. I've set up the magma collection so once it's erupted it'll create a long thin blade towards where the dropper will actually work. We set up the small amount of simple automation for this setup. We have an on-off and a timer connected to an AND gate. The AND gate is connected to a buffer gate. This controls the steel door, which will regulate how much magma is dropped into the system. Once we've turned the liquid magma into solid igneous rock debris, we need to collect it and extract the heat. For this, we're going to use window tiles and some lead. We're going to set up the second mechanised airlock to a temperature sensor. This section will transfer the heat from the diamond tiles directly into the petroleum, and from the petroleum that will heat up the crude oil as we drop it down into the chamber. We're going to use steel tiles to transfer the heat between the mechanised airlock and the temperature shift plates. In a second we're going to get a visual representation of how much magma we've actually got to work with. This is a very low volume volcano. It's going to be quite difficult to run for the first maybe 50 cycles or so, but after that, once the efficiency ramps up, it will be fine. I'll talk about how the efficiency ramps up later on. That's how much magma we have to run the boiler on. Well, that does not look like a lot of magma, but I'm positive this setup will run on that small amount, so let's get on with it. And here we are building our Petroleum Waterfall plus heat exchanger. Once the crude oil's been turned into petroleum, it will eventually overflow the heating chamber and cascade down this stepped area. The crude oil will flow in a pipe in the opposite direction and slowly heat up, and will hopefully be in the range of 380 to 390 degrees Celsius by the time it gets to the top. The crude oil will flow up the steps in copper radiant pipes. Just before the crude oil enters the petroleum boiler, I want to set up a liquid valve and a shut-off. This will give me the fine control I need when starting up this boiler. As you can see, I'm pre-filling the chamber with some petroleum. You have two choices when starting up a petroleum boiler. You either fill it up with petroleum or crude oil. The reason I don't use crude oil is because crude oil expands when you turn it into petroleum. Mechanics wise, there's less petroleum per tile than there is crude oil. So if you have a lot of crude oil flash to petroleum quickly, it expands and can do pressure damage to the chamber walls. I prefer doing it this way, it just removes an obvious risk. Yes, this does look slightly different and you might call shenanigans, but I had a crash with OBS and I lost a lot of footage. And then I had an interesting bug on Oxygen Not Included, where some magma skipped through the metallic lock into a metal tile and flashed all the petroleum to sour gas. So it's exactly the same build, except I used a lead temperature shift plate in the debris collection area. So we can see it all in action now. The airlock door opens, the magma blade flows and falls into the mesh tiles. It's then cooled via the temperature shift plate. It turns into debris and falls to the right out onto the diamond window tiles. The debris now transfers heat to the lead temperature shift plate, turning that lead molten, which then improves the temperature exchange between the igneous debris and the diamond tiles. I have used a fair quantity of diamond window tiles here. The idea behind this is thermal mass. It will help smooth out any of the temperature differences. A large mass takes longer to heat up, but takes longer to cool down as well. And with that and the slow release of the temperature from the igneous debris, it should be a nice efficient setup. And here we can see how the temperature is rising and being transferred through the diamond tiles. Okay, last warning for people that are photosensitive, the Petroleum Waterfall does strobe and flash slightly. So we're now bringing the heat exchanger online. We're still running petroleum through the system at the moment just to get this working. So our petroleum in the chamber is at 411 degrees Celsius. The petroleum in the copper pipes is reaching 355 degrees Celsius at the top of the stack. And here we have our first crude oil entering into the Petroleum Waterfall. So that's our petroleum boiler completed and gone through the startup procedure. Starting up a petroleum boiler is very energy inefficient. You have to heat a lot of liquid, either crude or petroleum, up to 400 degrees Celsius. As debris releases its heat slower than a full tile would, now we've paid the big cost up front of heating up all the liquids, we can use the slow heat transfer to generate petroleum at a regular rate now. In the next episode I'll get round to showing you running and converting crude to petroleum, but that will be in the next episode. Thank you very much for watching, and as always I'll see you on the other side.